Well, we have another question here that says, consider the following number pattern. Okay, we have the number pattern as you see there, 6, 13, 22, 33. And then the question says, show that it is a quadratic number pattern. Okay. We know the condition to have a quadratic number pattern is that the second difference are common. And in the quadratic number pattern, quadratic are of the form a n squared plus b n plus c. Okay. So the patterns are 6, 13, 22, 33, etc. Then we're going to look at the first difference, okay, of the pattern. So we do 13 minus 6, that's 7, and then 22 minus 13 is 9, 33 minus 22 is 11. Now we're going to look at the second, okay, difference. Then we can see so that was the first difference, and the second difference, D2, will be 9 minus 2 is 2, 9 minus 7, I mean, is 2, and then 11 minus 9 is also 2. Now the fact that this constant difference is common or is constant, then we can say that was A. The pattern is quadratic. Okay, and B, the question says write down the next two terms of the number pattern. So we can do that by knowing that the fact that we have a quadratic and the difference is constant, I can do a difference here. It must also be 2. So the number here must be 13 because 13 minus 11 is 2, or we can also do 11 plus 2 is 13. Okay, then we can find also this pattern by doing 33 plus 13, which is equal to 46. Okay. And then we also know the difference here will be, the difference here will be constant. It will be a linear pattern. Okay, the first difference must be linear pattern. So here it must be 15. So we do again 46 plus 15 is 61. So those are the two solutions. So we could just find here I can find 13 because here the constant difference, there's a constant difference which is 2. So I can just add 13 and it can be 15 and then 17 and so on and so forth. Because the first difference here forms a linear pattern. The first difference of a quadratic, of all quadratic pattern forms a linear pattern. So here at 13, then it's going to be 46. Here at 15, then it's going to be 61. Okay. So we say here, the terms will be like 46 and 61. Okay, and then C, the question says hence determine the nth term as well as the 100th term. So now to find the nth term, there are some formulas that I would like to list here. We need to know that A, the coefficients A here is equal to the second difference over 2. Okay, and then 3A plus B is equal to the first term of the quadratic pattern, and then A plus B plus C equal to, okay, not the first term, but the first difference. Okay, let me say here this way, T2 minus T1. Okay, and also A plus B plus C equal to T1. Those formulas are important. Okay, they will help us to calculate the nth term. So we can say that A will be equal to D2 over 2. So it's going to be 2 over 2. So that means A is just 1. Okay, and then 3A plus B will be T2 minus T1. T2 minus T1 here is 7. we got it over here. That's C2 minus, we sub there. And then A, we did find that A was 1. So we can just say 3 times 1 is 3 plus B equal to 7, okay? Now to find B, we can just move this 3 over. So move the 3 over is same as minus 3 here, you minus 3 there also. And then that means B equal to 4, okay? And then also A plus B plus C equal to T1, okay? This is like A, B, C, and then T1 there. T1 is the first term, which was 6. So A, we did find that A was 1, and then B, we find it to be 4, and then C is just the unknown here, C equals 6. So this makes what? 1 plus 4 is just 5, plus C equals 6. If I need to get a minus 5 here, a minus 5 there, to get the value of C, that makes C will be equal to 1. So now we have like A, we have B, and then we have C. We can write our nth term, which is Tn equal to an squared plus Bn plus C. So we can write it as Tn will be equal to A, which is 1, so 1 n squared plus B, which is 4, so 4n plus 1c. So or basically just Tn equal to n squared plus 4n plus 1. Okay, that's Tn. And the question says we need to find also the hundreds to calculate the 100 terms. So it's going to be like T. Wherever we have like n, we will substitute by 100. So plus 4n plus 1, we sub 100 over here. 100 there, squared, 100. So this will be T100 will be equal to, that makes 10,000 plus 400 plus 1, and then this makes that T100 will be equal to 10,400, 10,401. Okay. And then the question says determine which term. Determine which term equals to 118. So in this case, we're looking for let's say question D. We're looking for a certain term Tn. No, when I say determine which term, so there's a certain term which is equal to 118. Okay, so we need to find n to say what n is. What term number is that one? Okay. Now, to do that, we do know that Tn is equal to n squared plus 4n plus 1. So I'll substitute Tn by 118. So I'll write here n squared plus 4n plus 1. Instead of me writing Tn, I'll write 118. Okay, sub here 118. Then I can move it over the equal sign. So it's going to be like n squared plus 4n plus 1 minus 118 equals 0. That makes n squared plus 4n minus 117 equals 0. Now here we have a quadratic equation, a quadratic trinomial. We can solve this by factorization or by using the quadratic formula. So by factorization, for instance, I'll look at 117. Okay, it's the last term is negative 117. I can list all the factors of 117. Okay, if I do that, I'll see, I can see that this number is a multiple of 3 because I can do 1 + 1 + 7 is 9. 9 is a multiple of 3, so we'll 117. Okay, so this is divided by 3, so it'll be like 3 and 33, no, 39. Okay, and also by 9 it is equal to 13. Okay, or let's just check the calculator. If I do 117 divided by 3, that's 39, and then 117 divided by 9, and that yeah, 13. So we can then write like n in the bracket like that, and in the bracket like that, and close equal to 0. Then let's see which couple here will make a sum equal to the coefficient of the middle term. If you still struggle with factorization, we have a whole playlist of factorization. Okay, you can go there, revise, and then see how to solve by factorization. So now we need to see which couple will make a sum equal to 4. We can see with 9 and 13 we can, if this is a -9 and then positive 13. So -9 plus 13. Then we can do like this, means n minus 9 is 0, which means that n equal to 9, or n plus 13 equals 0, which means n equal to -13. Now, because there are terms, okay, a negative number is not applicable because it's meaningless. We cannot have like a position -13. Positions are positive integers starting from 1. Okay, it cannot be 0, it cannot be a negative number, it cannot be a fraction or decimal. So therefore it's T9, which is equal to 118. So that's the correct answer. T9 here. So, and we're looking, so when the question says that, excuse me, which term equal to certain amount, we're looking for n actually, and then we can say T9 equal to 118. Okay,